The Earth, the Moon, and the other planets in our solar system called as celestial bodies. The motion of these celestial bodies in our solar system has been a subject for many scientists. They were advised through the different scientific theories to understand the motion of these celestial bodies. According to this theory, the Earth is stationary and the center of the universe, with the Sun, the Moon, planets, and stars revolving around the Earth. This theory was accepted for almost 1400 years. According to this theory, Sun is stationary and center of the universe. The Earth and other planets move in perfect circles and also rotate about their own axis while orbiting around the Sun in circular orbits of different radii. But this theory was not accepted. This is because the accurate observations on planetary motion bearing the geocentric theory. In fact, the observations made by Kepler on planetary motion supporting the heliocentric theory. He introduced the concept that each planet revolves around the Sun in an elliptical orbit. Subsequently, Sir Isaac Newton focused on the motion of the Moon about the Earth nearly 60 years later. He assumed that the Earth attracts all the bodies towards its center. He also observed that it is not only for earthly bodies, but also every object in the universe attracts every other object. He termed such an attraction between the two objects as the force of gravitation or gravitational force. He explained the force of attraction between the Earth and the Moon with a law. This law is known as Universal Law of Gravitation. Let us discuss Newton's Universal Law of Gravitation in detail. Newton's Universal Law of Gravitation states that every object in the universe attracts every other object with a gravitational force, which is directly proportional to the product of their masses, and inversely proportional to the square of the distance between them. The gravitational force acts along the line joining the two objects. Since the law is universal and it is applicable to all the objects in the solar system, let us derive the expression for the universal law of gravitation. Consider two spherical bodies. Let m1 be the mass of the first body, m2 be the mass of the second body, and r be the distance between their centers. F is the force of attraction between the bodies. According to the universal law of gravitation, the gravitational force of attraction between the bodies F is directly proportional to the product of their masses m1 and m2, and inversely proportional to square of the distance between them. Mark these two equations as 1 and 2. By combining the both equations, we get the gravitational force between the bodies F is proportional to m1 m2 divided by r squared. Then, the gravitational force of attraction between the bodies F is equal to g m1 m2 divided by r squared, where g is the proportionality constant and it is called universal gravitational constant. If m1, m2 of two bodies represents each one kg and they are separated by unit distance, you get F is equal to g. Thus, the universal gravitational constant is numerically equal to the force of attraction between the two unit masses when they are separated by unit distance. The SI unit of gravitational constant is Newton meter squared per kilogram squared. The precise value of G was determined experimentally by Lord Henry Cavendish after Newton's death. The value of the universal law of gravitational constant is 6.67 into 10 to the raised power of minus 11 Newton meter squared per kilogram squared.